In this video, we're going to talk about the mean value theorem. The mean value theorem can help you find the point at which its tangent line corresponds to the secant line of the two x values in a certain function. However, before going to mean value theorem, we're going to take a shortcut in Rolle's theorem. The Rolle's theorem states that if the function is continuous and differentiable in a certain interval a to b, and that the y values at the point A and point B are the same, there must be one point where the first derivative of the function would be 0. So we'll have a little example. So we have a function of x squared minus 4 in the interval -2 to 2. It is continuous because it is a polynomial, so 100%. It is differentiable in open bracket -2 to 2, but not close bracket because it doesn't exist from the left on -2 and on the right on 2 because it has a restricted domain. So when we plug in -2 to the actual function of x squared minus 4, we get 0. So f of -2 equals 0, and when we plug 2 into the actual function, it is also 0. So f of 2 equals 0. That means f of -2 equals to 0, which equals to f of 2. So based on all three of these conditions, we can simply say that this satisfies the Rolle's theorem. So since it satisfies the Rolle's theorem, we can say that within -2 to 2 of x squared of the function x squared minus 4, there is a horizontal tangent line. So to find the point at which there's a horizontal tangent line, we have to get the derivative of x squared minus 4. So it will be 2x. For 2x, we have to plug in, well, we have to set it equals to 0. So 2x equals to 0. And then we find the values for x, which is simply x equals 0. So at x equals 0 of the function x squared minus 4 in the interval -2 to 2, there is a horizontal tangent line. To simply find the interval, just plug in the x value of 0 into the original function, which will be 0 squared minus 4, which is simply -4. So the interval at which there's a horizontal tangent line in the function x squared minus 4 will be at 0, -4. Moving on, we have the mean value theorem. It states that if a function is continuous and differentiable on a certain interval a and b, that there must be a point where the slope of its corresponding tangent line would be the same as the secant line, as the slope of the secant line running through the point AB. For a quick example, we will revisit the equation of x squared minus 4. But instead of the interval of -2 to 2, we will make it the interval of -2 to 3. First, we must state that the function is continuous and that it is differentiable on the interval of -2 to 3. This means that MVT would apply to this equation or function. Since this satisfies MVT, there must be a point where the slope of its corresponding tangent line will be equal to the slope of the secant line running through -2 to 3. Now, we must set the slope of the secant line and the derivative of the function x squared minus 4 together to find the x value of the point. After setting them equal to each other, now we have to solve for both sides to get the equation we want to get the x value. So it will be 5 minus 0 over 3 plus 2 equals to the derivative, which is 2x. We will have 5 over 5 equals 2x, which means that x equals half. This means that on the equation x squared minus 4, at the x value, x equal 1/2, which means that the y value would be -3 3/4. So at the at half, -3 3/4 on the equation x squared minus 4, there must be a corresponding tangent slope that equals to the secant line that runs through -2 and 3. When doing MVT and role theorem problems, always state the conditions and then state that they satisfy MVT or Rolle's theorem before doing everything else.